Energy-mass equivalence. We've probably all heard it mentioned, but what does it mean? A lot of times when physicists are making an interesting point about something, they will take E equals mc squared to mean E equals m, then never attempt to explain why they can just throw away c squared. That's what I'm going to talk about today. In a basic sense, any matter, or in other words, anything having mass, can be associated with a directly proportional measurement of energy. The subject is simple, and although controversial, it can be argued with pretty strong evidence that there is only energy in the universe, and matter doesn't even exist. Matter, or mass, is just a result of our relative observation of some of that energy. In this example, we're going to use a bicycle wheel as a reference structure. On the wheel, we'll mount a red lamp that will help to highlight motion. We'll also say the wheel itself is only for demonstration and has no mass, but the lamp does. In our first experiment, let's say we've come to a complete stop in the universe, so we can see anything that might go by. At this point in space, we wouldn't necessarily see anything interesting. However, when pure energy traveled past us, and if we're quick enough to see it happen, it would seem to make a waveform shape as it traveled across our view. As a side note, any visible waveform we could measure would only be a transient effect of the energy point. We refer to the effect as persistence of vision because the only visible part of that energy is the point itself. During our observation, we might see one packet after another traveling past, but we wouldn't find anything notable taking shape or even having any other shape than waveforms similar to this one. So how do you get matter from this? In our next experiment, let's speed up our own rate of travel to match that of the energy going by. What we see now is completely different. It should be pretty clear that when traveling in the same direction and speed as the energy point, there is no waveform at all, but a motion more closely resembling a circular orbit. So to clearly point out, in order for us to find and measure mass, we have to be traveling at roughly the same direction and speed as the energy point under observation. This also makes perfect sense within the overall theme of relativity. The direction is easy enough to find by following the path of the waveform. However, the speed of that energy relative to the viewer is what makes this discovery controversial. In order for mass to be equal to energy, that energy point, or mass in this case, must be traveling at the speed of light times the speed of light, therefore demonstrating the observation of E equals mc squared.